Today's going to be a little bit different of a video. The AP Calc FAQs have been released, and this is part 1 of 6 of solving the AP Calculus BC exam. Now, part A asks, find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. Show the setup for your calculations. If you remember the average value of a function, we can find that by doing 1 over b minus a integral from a to b of the function. And in this case, the function we want here is this c of t. And we have our bounds from 0 to 4. So we just have to find 1 over 4 minus 0 integral 0 to 4 c of t dt. We're going to do this in our calculator. So that gives us 2.778. Part B asks, find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval 0 to 4. So recall that we get the average rate of change by doing y2 minus y1 over x2 minus x1. This is our average rate of change, which we can find in our calculator by doing this, which gives us 1.282. So now that we have the average rate of change, we want to find when the instantaneous rate of change, or the derivative here, equals this number. We set our average rate of change equal to our derivative, which gives us this value of t, which we find to be 2.514. Now, part C asks, assume the invasive species continues to spread according to the given model for all times t greater than 0, and we want to write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species, and evaluate the limit. So we want a limit that describes the end behavior of the rate of change, or we want a limit of c prime. So we have a limit of c prime, but now we need to decide what we take t to. So the question says, assume the invasive species spreads according to the given model for all times t greater than 0, we can have t approaching infinity. And for this limit, as t grows to infinity, the denominator grows to infinity, which means this whole fraction tends to 0. For part D, they want us to find the maximum value of a in this interval. Remember that when we want to find the extrema of a function, we first need to differentiate it to find its critical values. So when we differentiate a, we go term by term, so c just differentiates to c prime. But for this term, since there's an integral, differentiating the integral just gets rid of it. So this reduces to 0.1 ln of t. Now we have to set this derivative equal to 0 and solve for t. Or we have to find when the graphs of this function and this function intersect in the interval 4 to 36. We're going to do that by plotting the functions on our calculator. So I've entered my functions here with x as a dummy variable, and then I graph. Then I'm going to go to my window here and set x minimum to 3 and x maximum to, let's say, 37. Graph now, we can tell that there's an intersection somewhere here. And we find this intersection by pressing second and calc. We find the intersection, this curve, and then it gives us our intersection, which is 11.442. And we can justify that this is a maximum by computing the derivative right before and right after this point. So I have my a prime in the function here, and then we're going to go to second table, and we're going to find a prime of 11 and a prime of 12. So if we put in 11 here, we get 0.0205, and if we put in 12, we get negative 0.024. So a prime goes from positive to negative. So the function goes from increasing to decreasing, which justifies why this is a maximum. And that's FRQ1. Be sure to tell me any mistakes I made in the comments and check out my page for the other 5 FRQs.